Today we will move to the seventh module, um, uh, emerging technologies and technology should be in cloud security. In cloud security, that's how it should be. And we'll just talk about everything in a place keeps on changing with time, depending on the new things that are coming. For example, if you live in a place where you wanna say your goats are never attacked by say hyenas or leopards, you the kind of fencing that you'll do there is just to restrict the goats from moving, and that one will basically mean you'll be in a position to be able to know how to deal with everything, how to deal with everything. Uh, yeah, so the goats will be moving, but within that, small, not so properly demarcated. But now, one day maybe, you wake up and you find two or three goats gone, and you realize it's a leopard. So you'll have to think for a way to now innovate a way to ensure that the goats are secure. And of course, you are going now to be caging them, okay, maybe inside a mesh, basically. So in that case, you are going. That is a new innovation that is going to come, and of course, that's maybe you may decide to come up with maybe CCTV cameras, and that's an emerging technology, okay, because of an event that has occurred, okay. So emerging cloud technologies are revolutionizing the way organizations manage and secure their digital environments, and innovations such as uh, edge computing, serverless architectures, and containerization are driving efficiency and scalability, but also introducing new security paradigms. So, and of course, when we talk about new security paradigms, we also talking about new, other kind of ideas over the same, because you can be able to see if you're having edge computing, that is where you're bringing computing, say computing gadgets close to where you store the data. You just bring the data center close to where they are. You're basically doing what we call edge computing. Think of it like putting something at the edge of something, okay? That is near, okay? Serverless computing basically means you don't really need to maintain a server. You just need to do something like function as a service fast. I think we did that. That is serverless. Like you only need to have a function as a service. You install, you host it in the cloud. That's serverless. You as the owner of the files, you really don't need to maintain those servers. They are not even close to you. And also containerization. We'll be talking about them as well. Uh, Now let's talk about edge computing. That's bringing computation and data storage closer to the location where it is needed. That's to enhance the response times and saving the bandwidth. Like so that it's like when you store something close to you. It's like, for example, you remember if you're having an Ethernet cable, say 100 meters from, say, a switch, maybe to the router, or maybe to the say distribution tower or point, to maybe to the router, the signal that will be received will be very slow, I mean a very low signal. But when that cable is shorter, of course the response times go high and also the bandwidth just the same, okay. So you have been given an example there where you can have sensors um, processing data and storing them near where they are, rather than sending them to the data center or to the cloud. Now, what are the challenges of edge computing? This is a very big challenge, by the way. As much as it's a new, technology, there is another increased attack surface. Okay, because in this case, you are having, if you're having these say sensors and these say data centers that are close to these points, maybe to the computing sensors, maybe computing, um, like, let me just say computers, you actually trying to spread them. Maybe if you have like 20 of them, they're in 20 different places, so you have actually increased the attack surface. Okay, in this case, one place is going to be attacked, another place is going to be attacked, another place is going to be attacked differently. Okay, so other than having them centrally, and of course trying to make sure that you have enhanced security measures, so you reduce that attack surface to only one. But when you have 10 of them, you increase the attack surface to 10 entry points. We also have weaker physical security. Unlike data centers, edge nodes may be deployed in public or unsecured locations, making them vulnerable to tampering or even theft. This very common. It actually happens. Yeah, it really happens, because imagine you have, say for example, you are an internet service provider, and say you use only point-to-point communication, so you have kind of entry towers, you have something like DPs, that is distribution points, maybe to other, maybe to say buildings. So you are not going to have every place being taken care by a soldier, for example, a security guard, for example. Assuming you have 2,000, you can't really have 2,000 security guys. Okay, so that basically means coming up with your own security company, training them, and of course deploying them, because 2,000 really is a lot. Okay, so there is always a weaker physical security. And then we also have inconsistency policies. You realize maybe in one place the security policies, the way they are managed is different. Maybe the manager is different, and the security policies are different from the others. And of course, there is that diversity in that security posture. Therefore, that also that you know make everything difficult in trying to standardize the security. Then you also have limited resources for defense. Um, Sorry, you may, for example, in a place have edge devices, say, for example, sensors. Now, maybe there is a very small, CPU that is running, even memory, storage, etc. Therefore, to run a strong security software in that given decentralized place where you have the data, the small data center close to the computing devices, makes it very difficult for you. Okay, and of course that space, you have to incorporate this security software in that memory. The processing power also reduces, maybe it is heavy, etc. Yes. Can they give me just nice? Okay. Okay, then we have data integrity and confidentiality risks. Okay, local storage and processing of data may increase the risk of unauthorized access, data leaks, or even malware infection. I mean, this is just very normal and very common, and that's a very big challenge for in edge computing. Firmware and patch management. If you have them centralized, if you have the data center centralized, you are going to update everything together, patch management, everything together. But now you have like 200 of these points, 200 of them. So you have to update these, go to the other one, update, go to the other one, update. Therefore, it becomes very, very hectic. You also have any compromised device can spread the threat. Like if, say, one node, one sensor has been compromised, all those sensors in that given area will be compromised. Okay. And of course, there is that. Of course, when you have edge computing, when you use edge computing, you reduce latency, and therefore there is that new security challenge that is being posed, and of course we have already talked about them. And yeah, so you can be able to see how difficult it's going to be for you as a company in managing them. So secondly, we'll be talking about serverless computing. That's same as function as a service, where a cloud execution model is a cloud execution model where the cloud provider automatically handles all server infrastructure, and users only deploy code that runs in response to specific events. Yeah, it's just like cloud as a service. Okay, and it of course enhances scalability and reduces operational overhead. If you really don't want to manage, you really don't want to manage a server. You don't want to have, to employ a network, saying engineer or anyone systems admin. Those are overhead costs. Therefore, it reduces them. Okay, even operational, you have coolers there. You need to have power. It reduces that. It also have some security implications. Um, they require robust security practices, very robust. Okay, for example, if you have your software, say, a function as a service application there, um, you have to make sure that you secure it properly, because you're not so sure about the physical server, how it is, whether it can be accessed easily. So you need to make sure that you actually have to use a lot of force in securing your application or even your software. Containerization. Okay, these are like, when we talk about containerization, we're talking about something like a container. Okay, we have several, but just give an example of Docker and Kubernetes. um, they package applications and their dependencies. So for example, you have an application. Every application has its dependencies. Okay, and therefore it enables that consistent, deployment across various environments. So when that container packages that application with all the dependencies that it requires, you can be able to, deploy it in whichever environment you want. And that is a very new approach that, is a new innovation that has come in. And most, I would say all companies that have cloud applications use containers, all of them. Security implication, containers, one container can be attacked by another container. It's as simple as that. But we call it container escape attack. So one container escapes, okay, and goes attacks the other. Or maybe one container gets compromised and then it goes and attack the other container. And of course, that's a malware, it goes and attack the other container. So you now get the difference between them, and you'll definitely, after these, I'll be, recommending another certification that you'll be doing, and of course, you will now be doing them practically. Okay. Yeah. So now let's talk about the impact of a is on cloud security again. Now, what is the impact? What is brought in? Those technologies. What do they bring, or what have they done? To the cloud security. Okay. So as new technologies get invented, there is a need to reevaluate traditional security approaches. For example, you're having edge computing, which is definitely distributed in nature. There is need to use decentralized security measures. So basically, um, because you know that you're going to be attacked, and of course you have edge computing practices, you are increasing the attack surface. You have to think of a way to ensure that the decentralized, way of your operations have proper or tight security measures. Okay. For example, serverless architectures, there is a need to secure individual functions and managing permissions. So you have like 20 FAS, function as a service, 20 of them. So you have to manage them individually, and you need to know that each function as a service has a different security measure. Okay, because if you are doing them together as like a badge of like 20 FAS, if the breach is done, one breach, it basically means you every FAS function, every FAS software, for example, application is going to be done. So the moment you're having like 20 and then you secure them independently or individually, you're actually increasing the lines of defense. Okay, if one gets attacked, that one will survive anyway. Maybe as you try to, maybe you revive the one that has gone down. But if you put them together again, you understand what it means. Once the attacker gains access, that is it. 20 of them are going to go down. Okay, so basically that that needs organizations to be very flexible and agile when it comes to implementing security in the cloud, especially when they have, for example, either edge computing or even serverless computing. They have to be very flexible. They have to think every time on how to change to adapt to the changing patterns of attack. Let's talk about AI and machine learning in cloud security. Okay, so AI and machine learning. Let me just talk about this. Yeah. So AI basically it's like creating an artificial human brain, that can be able to help you. Maybe when you're tired of thinking and you think that maybe something needs to be done with some activities, you use robots. Okay, for example, learning basically means maybe you need to create systems that are able to detect some kind of anomalies or to predict the probability of an attack happening because of some activities that are being done, or maybe the behavior of the firewall, etc. Okay, having the data, training the machine learning, the models, and making sure that you have a system that enables you to detect and maybe to either stop or to even make you know that something is happening. Okay, so AI and machine learning or ML are transforming cloud security by enabling systems to detect, predict, and respond to threats in real time. And by the way, it's real time. You don't need to detect right now, and it's like tomorrow where the response is going to be. This is real time. And of course, it's going to be faster. They're always faster and more accurately than the traditional methods of, say, for example, you have an alarm going, and of course, you have to send, say, security personnel somewhere. Maybe a server room has been, attacked, or maybe someone is trying to access, etc. But when you have these systems, it makes your work easy. So, assuming now you have a system, and of course it is in place and it's working, and you realize that maybe you have collected enough data. Say, let me just say this way. Say, for example, you have a credit, you handle credit cards, and you realize that maybe people are making purchases from you, maybe plus their details, or maybe you're a bank and maybe people are trying to transact money, maybe doing withdrawals. Okay, and there are some moments where some fraud happens. So you feel like, okay, fine, 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 what can I do? Maybe you have like 2 million records, and you have few cases, maybe could be maybe 3,000 fraud cases, and the others were genuine transactions. You may decide and say, okay, fine, because of this data, I need to create a machine learning model, deploy it in the system so that any such a transaction that has these features happens, then the system flags it as possible fraud, and therefore it suspends or stops the transaction. Okay, and that is basically how it happens. That's a machine learning model. So in AI, we use that to ensure that we use the same. It's almost the same as machine learning, but AI is advanced. Is a more advanced approach than machine learning, where now the system now thinks like a human being would think. Now it's making decisions on your behalf. If it is stopping a transaction, for example, happening, it will stop and send a notification without you doing anything to the person transacting that this cannot be done this way. You need to visit maybe our, say, maybe offices, something like that. Okay. So in cloud security, you can have the same. Any access is stopped immediately when it's not, it's a normal, not a normal access. Say someone, maybe a user trying to log in at night, maybe to say maybe 2 a.m. And that user normally comes to the office between, maybe works between 8 and 5. So when it looks at the abnormal activities of this user accessing the system, it automatically suspends the account and it requires them to be in the office between this time and this time, or even to contact the admin immediately. So basically, that is how it works. So when you integrate AI and ML to cloud platforms, there's technologies which are ML and AI automate threat detection, improve decision making, and also enhance uh, compliance. Now let's talk about the key concepts here. We already mentioned these, but let's talk about them. So AI, of course, the simulation of human intelligence by machines, enabling automated reasoning, learning, and self-correction. Now, in this case, the AI system looks at the activity, checks how it is, it keeps on checking and relearning itself. It's like when you are doing an exercise, not an exercise, but when you're learning and you read, maybe you do a math, then you fail, then you go sit down and look at yourself. Look, what did I fail? What did I fail? Then you go back, look at it, then learn, correct yourself, and then redo again. Basically, that is how AI is. So any activity, okay, if for example it detected that a user was wrong, was not was a genuine user attempting to access the machine, then they grant maybe an application or system, they grant permission, they access. When they access, then the AI system realizes no, this wasn't the normal user, it was actually, say, an attacker. Then it relearns itself and checks all the activities that this user was, or maybe let me say the interaction between the user and of course the system. Then it relearns, it is corrects itself, and then it says next time I will be able to handle this case this way, this way, this way. Okay. Then for machine learning, it's actually a subset of AI. It's a small part where the system learn from data patterns and improve performance without being, explicitly programmed. Like you're not there programming it every time. So you just key in the data, and of course keeps on making the predictions every time. And giving more data, it also looks at it, checks, and sees different patterns coming in. Also, it also keeps on improving how it functions and how it performs. Behavioral analysis. Okay, we have monitoring user system behavior. That is, you can have create a system that, of course, you incorporate all these. You can incorporate AI or even ML to just be able to see, how a system, or maybe a user, say, access, is this user an attack or just a normal user? And they are threat. Okay, so when they realize that this behavior that we know this person actually do or does, we don't think this is the real person. That's the same way I said maybe logging in at 2 a.m. They look at it and say no. I mean, no, it's not normal. Then or maybe some activities, say someone just accessing and then accessing a system. Yes, you access the systems, and then you are accessing some specific systems at the same time, like you have 10 of them opened, like active, that is an abnormality. I mean, that's not really normal. Okay, so that's behavioral analysis. Then anomaly detection now is where, I think that should now be the one where you have the, a user that is used to going to the office at 8, using the system in the office. Now they're remotely accessing the system at 2 a.m. That's really not a normal pattern of the person or the user, and therefore it could indicate um, maybe a sabotage attack or even a misconfiguration of the system that is being accessed. All right. So those are some of the terms that we use when you're talking about AI and machine learning in cloud security. So we normally use all these to ensure that we implement all of them when we want to automate our security, the security on our systems. Now, utilizing AI and ML for threat detection and response. First, we have threat detection and anomaly identification. Now, the machine learning algorithms analyze large volumes of, say, network traffic, okay, user behavior, and system logs. To detect one, you can detect zero-day exploits. You can detect, say, insider threats. You can detect malware behavior. Okay, so when you use it, it basically gives you a leeway. Okay, that you are either maybe having these and these and these. So when you have all that data and the algorithm that you have used maybe to train your machine learning model is is well configured to be able to identify the three of them, then you are you are really doing well. So when you talk about zero-day exploit, is it's kind of a cyber attack that takes advantage of some unknown or unpatched, say, software. Say for example, you have taken for long without updating maybe the software, or you have not patched the security features, the new security features. Now it attacks that given vulnerability that is there. So that is what we call zero-day um, uh, exploit. That is, uh, of course, you understand inside threat, and of course malware behavior. That's malware is behaving in a different, I mean, in a way, these are malware. So a malware behaves this way. So when you have a machine learning system, it will be able to identify that these are malware. The way it is trying to access these, it is trying to, it's kind of maybe trying to bring in a DOS attack. So it basically detects it. Okay. For example, there is this Google Cloud Security that is there. It's called Chronicle Security. Okay, it's actually for Google. We call it Chronicle Security. It uses ML to identify unusual login patterns. Okay, and DNS anomalies that may indicate maybe phishing or even command and control kind of activity. So, for example, when you have maybe someone trying to access, and the system is looking at it like, okay, we are not so say used, maybe the system knows that this is not the normal behavior, or maybe it has already been trained that this is how this works. So it just knows, like, "Oh, I already know you, so you're not going to attack us," and therefore you store they will block, they will immediately block. Okay, the DNS, basically, that is a I believe you know this, domain name system. It should be domain name system. Yes. Then let's look at the next. The second one, let's talk about security information and event management enhancement. Okay, so we have some, SIEMs. We call them SIEMs. Okay, security information and event management, systems. Okay, if when they are AI powered, and of course there's some examples here. QRadar, as for IBM, Azure Sentinel. They inject logs and security events from across the cloud to one, correlate incidents automatically. Okay, an incident that has happened, it gets correlated automatically. Prioritize threats using scoring. Okay, like which one is more dangerous than the other. Okay, like okay, you have like 20 threats, so which one is more dangerous among the 10? You prioritize them and you put them in a way that you are able to pick the one that is very dangerous, hazardous, then you stop it, then you move to the next one that ranks again, you move until you are done with the least one. Then first of all, we talked about correlating incidents automatically, prioritizing threats, recommend remediation steps. Okay, you can actually come up with that system, AI system. Actually, that's how QRadar and Azure Sentinel work. Okay, they always do all this. We also have identity and access management, that is IAM, where you have, for example, a machine learning system that can be able to help to detect abnormal user login behavior, such as login from unusual locations or even devices. Maybe it's a new device that has never been used to access the system and it's now accessing maybe and of course a different IP address. Maybe someone is logging from, say, Dar es Salaam, and they are normally used to log in when they are saying Entebbe or even say Kampala. Okay, so you can actually be able to implement all these using AI and machine learning. Then we also have automated incident response, where there's an incident that has happened. The response is automated, and therefore you're able to deal with the issues that are there. Not, like you as a person, but the system deals with the issues. Okay, say for example, quarantine compromised virtual machines. If a virtual machine has been compromised, it gets quarantined and separated from the other to isolate affected storage buckets. If a bucket has been affected, maybe there was some kind of misconfiguration or maybe malware, it gets isolated. Trigger alerts, you can be able to automate triggering of alerts if someone is trying to attack, and therefore, of course, at the same time, an initiation of a remedy can be immediately also triggered to be able to stop the attack. Okay, they can also be used to suggest security policies automatically. Like we need to, maybe if you need new security policies, they can be the IAC system can be able to suggest the new policy security policies. Sorry. Also, fraud detection and behavioral metrics. For example, in e-commerce, you can be able to detect suspicious transactions. I think I already mentioned this. I think when I talked about coming up with a machine learning system to detect fraud transactions. Okay, and also even typical, you can actually come up with an AI system that looks at the movement of the cursor or even the mouse, even the typing speed, and flags that is that possibility of an impersonator. Okay, maybe someone trying to access the system, maybe the typing speed is the person has already been captured by the system. This is the system, this is how you type, but in this case your typing speed is so fast, or even it's so slow, like there's something that's really fishing, not really working well, so they're able to detect the same. Then finally we have malware analysis and classification. Yeah, you can have an AI system that picks malware, scans the files, then picks, and when it identifies it, it classifies to maybe one is more contagious, one is just easy to deal with, etc. So you can actually even have it to just be able to pick different files, analyze them, put them in different kind of containers to be able to maybe inspect it even more. Okay, so models can can scan files and network packets to identify known and unknown malware families based on code patterns, for example, or even sandbox simulations. And therefore AI is one of the best currently, and it's really trending. Everything, like most people are actually adopting AI, and one is really one of the best technologies that is currently being employed in cloud security. So that marks the end of today's class.